Hi, let's start with our chapter number 4, Chemical Formula and Equations. Introduction to Chemical Symbols and Nomenclature. Historical context. Developed by Swedish chemist Johannes Jacob Berzelius, 1779 to 1848, designed to be universally understood across languages, provides a standardized system of chemical representation. Key characteristics of chemical symbols. Its universal language transcends linguistic and cultural boundaries, unique symbols for each element, not always based on English names. Example, tungsten is capital W, comes from German Wolfram. Recent element discoveries, new elements in periodic tables, bottom row, nihonium NH, discovered in Japan, named after Japanese country name. Moscovium MC, named after Moscow region, discovered at Joint Institute for Nuclear Research. Tennessee TS, recognized, researched in Tennessee, USA, linked to Vanderbilt University and Oak Ridge Natural Laboratory. Oganesson OG, named after Armenian nuclear physicist Yuri Oganesson, represents cutting-edge element research. Chemical equations. So, word equations definition describes chemical reaction using substance names. Components. It has reactants and products. Reactants are substances entering the reaction, and products are the substances produced in the chemical reaction. Example is magnesium plus oxygen gives magnesium oxide. Hydrogen plus water gives water. Balanced symbol equation. Law of conservation of mass. Total mass of products equals total mass of reactant. Atoms are rearranged, not created or destroyed. Balancing equation steps. Remember, identify reactants and products. Write initial unbalanced equation. Adjust coefficients to equalize atom numbers and then verify atom count on both sides. Key principles here is cannot change chemical formula, only modify coefficients. Ensure equal atom count. We have now the reaction types. Number 1 is elemental reactions, direct combinations of elements. Example, metal reacting with oxygen. Then we have compound reactions, involve compounds as reactant or products. Example, potassium reacting with water. Now, some practical consideration here includes diatomic molecules. Some elements exist as two atom molecules. Example, oxygen O2 and chlorine Cl2. Important when writing balance equations. Let's talk about energy in reactions. Chemical equation represents substance transformations. Energy is not included in the equation. Exothermic reactions produce heat, light. Let's talk about reaction patterns. Alkali, metals and water reactions. General reaction pattern here is alkali metal when react with water, it provides metal hydroxide and hydrogen, consistent across all alkali metals. Some key terminologies which you should know. Word equation, which means that it describes reactions using substance names. Symbol equation is actually uses chemical formula to represent reaction. Reactants are the substances entering a chemical reaction. Products are the substances produced in a chemical reaction. Coefficient, number placed before chemical formula to balance the equation. Now let's talk about atomic mass and compound formation. Here we start with isotopes and relative atomic mass. So let's understand isotopes first. Definition is atoms of same element with different number of neutrons. Discovered through mass spectrometer technology, most elements have multiple isotopes. Key insights here is that isotopes variation cause slight differences in atomic masses. Now, for calculating relative atomic mass, average mass of an atom considering neutral isotope proportions, typically rounded to nearest whole number. Exception is chlorine's atomic mass, which is not rounded. Important note is here ion mass equal parent atom mass. Now let's talk about relative molecular and formula mass. Calculating molecular mass. Method is add relative atomic masses of atoms in a molecule formula unit. Applies to different substance type. Number 1, covalent molecular substances. Number 2, ionic compounds. And then number 3 is giant covalent compounds. Compound formation principles. Experimental observations include that compounds always contain elements in fixed proportion, consistent elemental ratio, regardless of preparation method. Practical experiment magnesium oxide formation in a laboratory. Heating magnesium in a crucible with controlled air exposure demonstrates fixed ratio of magnesium to oxygen. Percentage composition, you can calculate percentage of each element in a compound. For example, sulfur dioxide 50% is sulfur and 50% is oxygen. Some key terminologies here to know is formula unit, basic unit summarizing substance composition, relative molecular mass, sum of atomic masses in a molecule, relative formula mass, sum of relative atomic masses in a formula unit, and water of crystallization, water molecule incorporated in salt crystal structure. Some calculation strategies, reacting masses, use chemical equations to determine reaction proportions. Calculate product masses based on reactant quantities. Technique proportional scaling of known reaction data. Some advanced concepts here are chemical stoichiometry, precise quantitative relationships in chemical reactions, enable prediction of reactant quantities, product yields, and elemental composition. Some practical applications are quality control in chemical manufacturing, pharmaceutical research, and also used in environmental monitoring. Chemical formula and equations. So number 1, chemical formula basics. You should understand some chemical representation. Chemical formula represent elements and compounds using the symbols of element and the number of atom in a molecule. Types of formula: simple covalent compound formula, or the complex covalent compound formula, or the ionic compound formula. Empirical formula is the simplest whole number ratio of atom or ions in a compound. Represents the most basic structural composition. Chemical equations. Okay, we have types of chemical equations. Word equation, it describes reactions using words. Symbol equation, it represents reaction using chemical symbols. And ionic equations, so we have these three types. Ionic equation is specific representation for ionic reactions. Key symbols, here we have state symbols which indicate physical state of reactant and product. For example, S for solid, L for liquid, G for gas, and AQ for aqueous solution. Now let's talk about chemical formula and molecular structures. So molecular formula, basics and identification. Definition is a representation showing the actual number of atoms of each element in a molecule. determined by counting atoms in a molecular diagram. Used directly